So in this example, we are again given the HNMR values chart. So it is between 0, 1, 2, 3, 4, 5, and it goes on. Okay, so 0, 1, 2, 3, 4, 5. Now the readings are given here. One is for within this one, and another is between here. So here we have some like multiplate, and it is saying the HNMR is of some RBR, that means some halogenoalkene. Okay, this is an HNMR for a halogenoalkene. Now, there we have, they are saying this is 6H, that means there is 6 hydrogen, and there we have 1 hydrogen. And the M is to M plus 1 is given as 5.9 is to 0.2. Anything else given? No, nothing else is given. So pause the video, try it yourself, and the rest you will be trying it together. So here, the number of carbon atom is given as 100 over 1.1 into 0.2 divided by 5.9 equals to 3.08, which is actually approximated to 3. That means 3 carbon should be here, and we have 2 chemical environments. Okay. Now it says here we have a what? Doublet. A doublet is when the neighboring carbon has 1 hydrogen only. Okay? But it is saying this carbon, I mean this carbon which we are talking about, it should have 6 hydrogen. Okay, so from our previous example, we got to know that if this such type of things are written, that means what? There should be actually duplication. This should be a possibility. Okay, so its neighboring carbon, I mean, like there's a CH3, another CH3, both are having a CH group. Now you might be saying previously we did it like separately. Why now in this case not give another carbon here? Because see the number of carbon here, we have 3. So if I give another carbon, that will violate our like the requirement. Okay. Now since we have 3 possible carbon, so this is a possibility, is the structure. And see about this multiplate, this carbon's neighboring carbon has, we have neighboring 2 carbons and total 6 hydrogens. 6 plus 1 is 7. That means actually this represents a multiplate. And they have mentioned this is a RBR. That means the BR is going to be here. So this was quite simple in this case. So we can say about the readings that between, like for the CHC group, the reading we got was for 1.2 to something. Okay. And for the part of, let's say, let's go to the data booklet in this case, because we need the data booklet. Let me clear this up. Now, over here, do you have any halogen alkene? Yeah, we have a halogen alkene here present. We draw it with a different color. So here, see, in this portion, in this region, this could be a possibility. Okay, so see, the CHBr is directly given here, which is between 3.2 to 4. And moving back to our chart here, it is between 3.2 to 4. So that means because of the CHBr group, we got a reading from 3.2 to 4. And this was, let's say, 0.9 to 1.7, just writing the whole range. Okay, so this is, or these are the possibility in this case. Okay, so this example was quite easy, I would say. But no worries, if you couldn't solve, after watching the videos, after watching the lecture and the solution, pause the video, try it after 1 to 2 hours by yourself, observing the question, write it yourself, try all the questions so far, do have repetition. Okay, regularly try to observe the notes and the lecture examples. This will actually help you to solve the future questions. The next example is given as, we have count 0, 1, 2, 3, 4, And we have a count at the 2 and the between this 3 and 4. Okay, we have 0, 1, 2, 3, 4. Like this is the structure given. And nothing else is given here. Okay, so we are supposed to find something. Let's see. Like in my question here, nothing is given. So let's see what could be a possibility. We have two chemical environments. Okay, two chemical environments. I think they should give this part. So this must be given. So CH3H6O2, this is the molecular formula. We are supposed to find which of this, like which of the molecule having this molecular formula should represent this sort of structure. Okay, remember this sort of question might come. Okay, so the molecular formula is given. Now we need to find simply, okay, what could be a possibility? Like there could be many isomers. We need to find one such isomer who has two chemical environments and each having one singlet, just a singlet. So the singlets are there. So let's see what, like just simply draw the first one without like having like any sort of like idea. So this is a possible, like this is the first isomer, but see here we have 1, 2, 3 environments. So this is in the first situation without observing how many peaks we have. This is a no. Coming to the next word, let's see. We can have an ester. Now, how many environments we have? We have one possibility here, another possibility, another two possibilities are there. Okay. Now, like ester itself does not give us any environment. Let's see if it does or not. Let's see the data booklet. Ester, does it give itself any? No, ester itself does not give any environment. Okay, so yeah, ester itself does not give any environment. That means we have to observe about the double bond O. See, double bond O. Okay, so ester itself won't give us any environment. That means the two possible environments are, this is one environment, this is another environment. I mean, this oxygen itself is another environment. Okay, this is, and this is another environment. These are the two possible environments. Okay, so yeah, we have two environments here. And let's see, this carbon's neighboring carbon has 0 carbon. That means, I'm sorry, the 0 hydrogen. That means 0 plus 1 is 1, like singlet. And this carbon does not have any carbon, like neighboring carbon atom. That means that also itself has, okay, no, this is actually CH3O. This is a CH3O group. So CH3O group, that is going to give us a like single group. Okay, I'm making it complex. So there are actually two groups. One group is actually CH3. This is one group, one of the group. Another group is this one. Okay, this is another group. They are bonded. So we have actually two groups here, one, here, one. Now, how do I know that? Let's go back to our structures data booklet and observe here. Here is this group, CH3CO, and there is CH3O group. Okay, so these are the two groups. One is at 2.223 and it is 3.224. 2.223 is our CH3CO group. CH3CO. So our this group, where it went, wait, where did it go? Yeah, 2.2, this is for CH3 C double bond O, and this is for CH3. Oh, now how do I know? Because since they have given us the reading, I'm just marking that this could be a possibility. And since our structure has this CH3, CH, like all this group, I'm just mentioning in terms of them. So here we should have that single oxygen bond. And observe this, these bonds, neighboring carbon has how many oxygen? I mean, how many hydrogens are there? This neighbor carbon has no hydrogen. That means 0 plus 1 is singlet. Okay, and this portion's neighboring carbon, sorry, not that portion, this carbon itself, neighboring carbon has how many hydrogen? 0 plus 1 singlet. So this itself is a singlet group, this itself is a singlet group. They're like special groups, we can say. So we got singlets here in this case. So that means a possibility of our structure is this is the isomer they're being talking about. So this portion, which is CH3O, this gives us a reading from 3.2 to 4, and CH3 C double bond O, this gives us a reading between 2.2 to 3. Okay, so that's all for today. We'll be doing more examples in our next class, inshallah. Take care. Assalamu alaikum.